Okay, so if you were absent today, I could not get the notes to work. I could not get the recording system to work when we started. So I'm going to do real short notes just to make sure that when you come in tomorrow, you'll have an idea of what we did. But then I'm going to send pictures of the other examples. So the notes we did today were on the area between two curves. And here's the basic gist. So when you are finding the area between two curves, we'll say between f of x and g of x. For f of x greater than g of x on the interval from a to b. It will be defined by, okay, and then we're going to sketch a little picture here just to kind of explain what's going on. So let's say that our f of x is here, and then our g of x we'll say is down here. And let's say that a is here, and b is here. Okay, what I want is only the area that is between these two curves, right here, from A to B. So notice that when I shaded, I started here at A, but then I stopped over there at B. So this is the area that I want, okay? So then the way that you would do that, just kind of think about here. I'm going to take the area that's under the function f, so it'd be from here all the way down to the x-axis. So all of that yellow area. And then I'm going to minus out this area that's under G. And then think about what's going to be left over is this area in the middle. So it would be area equals the integral from A to B of f of x minus g of x dx. Now you are also allowed to separate those integrals. A to b of f of x dx minus a to b of g of x dx. Hey, what's up? I'm recording.
Am I supposed to buy the cords from you?
Yes. Can you come back before you go to lunch?
Okay.
During lunch.
Okay.
And I'll give them to you then. Do you have $2? Okay, then you can just buy them another day. You just need $2.
Okay.
Okay? So either one of these is fine. So you can put them all together in one integral, or you can put them separate into individual integrals. Okay? So quick little example here. We are not going to work these all the way out. We're mainly going to practice setting up the integrals. So let's say that you wanted to find the area enclosed between f of x equals, we'll say 4 minus x squared, and g of x equals, let's say 20. Okay? Actually, hold on. Don't make it a 20. Make it a negative 12. Sorry. Okay, so first thing that we're going to do is we're going to set up our graph. Okay, so think about 4 minus x squared. 4 is going to be the y-intercept. So 1, 2, 3, 4. We'll say it's right here. And then negative x squared is going to open down, just like that. Okay? Then g of x equals negative 12. Well, that's going to be a flat line. So we'll say negative 12 is down here. Draw your line in across. Okay, and we have our two graphs. Well, then if I want the area that is only between those two graphs, then I'm only going to shade from the first intersection over to the second intersection. So when I set up my area, it's going to be the integral of the top function minus the bottom function. So my top function is 4 minus x squared. That's going to come first. Minus the bottom function is negative 12. Now, as far as these endpoints go, for me to know what to put here and what to put here, I'm going to need to find these intersections on my graph. The way that you find those intersections is by setting the equations equal to each other. So find intersections. I would let 4 minus x squared equal negative 12. So first thing I'm going to do is minus my 4 across here. Negative 4 minus from 12 is going to give me negative x squared is negative 16. Get rid of the negatives. Square root both sides. X is plus or minus 4. Which means that this side over here is negative 4. This side over here is positive 4. And then remember that when I set up my graph, I want to make sure that that these points here are my endpoints on my integral. Then from there, I'm going to combine this into one big integral, and then I'm going to do my antiderivative. So it'd be negative 4 to 4. Negative x squared, I'm going to let come first. And then if it's 4 minus negative 12, really that's 4 plus 12, which is going to come out to be 16 dx. And then I'll do the antiderivative. So it'd be negative 1/3 x cubed. Antiderivative of 16 is 16x. Plugging in 4 and negative 4. If I plug in 4 first, 4 cubed is 64. So that'd be negative 64 thirds. And then plus 16 times 4 is 64. Other side here, I'm plugging in a minus 4. Negative 4 cubed is negative 64 times negative 3 is positive 64 thirds. And then over here I have a 16x, plug that in, that's a minus 64. Then remember, it's top minus bottom. So it'd be negative 64 thirds plus 64 minus 64 thirds minus 64. And so then from there, I'm going to combine like parts. So negative 64 minus 64 more, that's going to give me negative 128 thirds. And then if I have 64 minus negative 64, that's really a plus, so that'd be plus 128. Okay, and then that's good enough for your total area. Now I do want you to just consider for a second that if this is 28 minus 28 thirds, overall that is going to come out to be positive. Okay, because this is going to be less than 128. Okay? Alright, let's do another one, please. So let's say for our next example that our function is going to be f of x equals and it's going to be x squared and 2x plus 8. Okay. So in this case, I'm going to sketch my graph just like last time. X squared opens up, we know that one. And then 2x plus 8, that's linear. It starts at 8. And then if it's a 2x here in the front, that means that it is headed uphill. Okay, so we don't know exactly everything about the graph, but we at least know enough to sketch it. Then I'm shading this pocket here that is between them. So when I set up my integral, it's going to be area equals, and then it'll be the top function minus the bottom function. So I have to be very careful about my order here. My x squared, which they gave me first, is actually the bottom, not the top. So my 2x plus 8 is going to have to come first in my integral, and then my x squared is going to have to come second. Because remember, it's always the top minus the bottom. Okay? Then from there, I want these endpoints here. In order to do that, I'm going to have to set them equal. So to find my intersections, I'm going to set x squared equal to 2x plus 8. And if I do that, then I know that my 2x plus 8 is going to move over and turn negative. And if it's a minus 2x and a minus 8, then when I factor that, it's going to come out to be x minus 4 and x plus 2. Now remember that those parentheses are always going to be the opposite of your actual values. So that means that this one is x equals 4. This one is x equals negative 2. And when I put them here on my integral, I need to make sure the smaller one goes on bottom. So negative 2 is my smaller value. 4 is my larger value. And then this one, again, I could do this one by hand pretty easily. So it'd be antiderivative here would be x squared. Notice that when I increase the power and divide by 2, the 2 goes away. Plus 8x. And then over here, that'd be minus a third x cubed. Okay, then from here, we'd be plugging in 4, then plugging in negative 2. Let's do 4 first. 4 squared here is 16 plus, and plugging in 4 there, that'd be 32 minus, and then 4 cubed here is going to be negative a third of 64. And then 16, and that is going to be 48 minus 64 thirds. Okay, that's my top value. Now we're plugging in negative 2. Negative 2 cubed is going to be 4. Okay, then plug in negative 2 here, minus 16. And then when I do negative 2 cubed here, it's going to be negative 8 multiplied by the negative on the third. And that's going to come out to be, that's going to come out to be positive 8 thirds because you cubed it negative. So 4 minus 16 is negative 12, and then plus 8 thirds. And then remember, it's this minus that. So it'd be 48 minus 64 thirds minus negative 12 plus 8 thirds. Now, the way that I have that written is incorrect because I don't have parentheses. Specifically, you really just need the parentheses here because not only am I minusing the negative 12, but I'm minusing the 8 thirds as well. So I have 48 minus negative 12 is going to be positive 60. And then if I have negative 64 thirds minus 8 thirds, that's going to give me negative 56 thirds. And then that would be your answer for area. Okay. All right, I'm going to do one more like that just to kind of give you the idea. And then, like I said, I'll send you the examples we did in class as well. Last one, let's say that you have f of x equals root 2x and g of x equals 4 and the y-axis as your third side. So let's think about the graph of this for a second and why you even need a third side. So square root 2x goes like that. G of x equals 4 is flat. So the problem is that when I start shading, I'm going to start at this intersection, but then it's like these don't ever cross again for me to know where to stop. So when they tell me the y-axis, they're telling me this is my other side that I need to stop there. So I'm going to let this side be x equals 0. This side is my unknown that I'll have to find. So it'll be area equals the integral top minus bottom. My straight line is on top. My curve is on bottom, so it'd be 4 minus root 2x dx. My lower bound I know is a 0. My upper bound I'm going to have to find. Remember, the way that you find that is by setting them equal. So root 2x equals 4, and then we'd solve that. So square, square. That gives me 2x equals 4 squared is 16. Divide by 2, x is 8, which means that this point over here is going to be my upper boundary in my integral. Okay, then from there, when you look at this integral setup, you should notice that this part back here is going to require u substitution. Okay, but the 4 in the front is not. So this is the situation where, I don't know if you remember, but in the very front of our notes I'd said you can write it all together as one, but you're also allowed to split them up each into their own integral. So this is what we're going to do on this example. So I do the integral of 4 from 0 to 8 minus the integral of root 2x from 0 to 8. Okay, the 4 one is going to be super easy. Antiderivative of 4 is 4x. We're going to plug in 8 and 0, and then we're going to subtract. Plug in 8 there, 4 times 8 is 32. Plug in 0 there, 4 times 0 is 0. 32 minus 0 is 32. Now, rather than putting the minus here in the middle, I'm going to change that to a plus, and I'm going to put the minus inside the integral, just so that I don't forget about it. And then this part, as we said, is going to need u sub. So I'm going to pick my u to be 2x. And if my u is 2x, then my du is 2 dx, which means that dx is du over 2. So all of that, hopefully you remember how to do from when we learned u sub. So then when I rewrite my integral, it's going to be the integral of negative square root u du. And then instead of putting my over 2 on the inside, I'm going to put a half on the outside. And then really, actually, I'm going to put the negative out here as well. Now, there's one other thing I'm going to have to do on that. I can't leave my u under a square root, so I'm going to change it to a 1/2 power. And then the other thing, hopefully you remember, is that these endpoints have to be plugged into your 2x. So if this is an 8, I plug in 8 to 2x, my upper bound is now a 16. This was a 0, plug into 2x, it stays a 0. Then for your power rule, negative 1/2. Okay, I'm going to add 2 over 2 to 1/2, because remember you have to add 1. 2 over 2 is the same as 1. 1/2 plus 2/2 is u to the 3/2. Then if I have to divide by 3/2, that's the same as multiplying by 2/3. And then I would go ahead and cancel those 2's out, just since they're kind of repetitive. One on top, one on bottom. Then from there, we're going to plug in capital F of 16, then capital F of 0, then subtract. Let's do 16 first. So I have a negative 1/3 here in the front. And then I have 16 is going to be raised to the power of 3. But then the divided by 2 is actually a root. And remember, when you go in order, you're going to do the root first. So the root of 16 is 4. 4 cubed comes out to be 64. Then when I plug in 0, negative 1/3 times 0 to the 3 square rooted is going to be 0. Then remember, if I do top minus bottom, I just end up really only with the top here. So it'd be plus negative 1/3 of 64. Okay, now remember what we had said at the beginning. You could keep this negative out here, or you can put it on the inside, but either way, that second piece is usually going to come out to be negative. So you can think about it as a subtraction, or you can think about it as adding a negative. It doesn't matter which one. Okay, the last thing that we talked about, we really only got to one example of this in third period, but it's taking area with respect to y. So if you are taking the area between f of y and g of y, on the integral from c, on the interval from c to d, that would be your range, then it would be defined by area equals integral c to d f of y minus g of y dy. And then here's kind of a picture just to go with that. So if your functions are f of y and g of y, that means that they're with respect to y. So instead of passing the vertical line test, they're going to pass the horizontal line test. So we'll say that's f of y, and then let's say that this is g of y. So then my area in this case is still trapped between the curves, but you'll notice that it just looks different because instead of your functions being with respect to x, they're functions with respect to y, which means that they're going to pass the horizontal line test but not the vertical line test. Okay, so then keep in mind you're also allowed to still split these up. C to d of f minus C to D of G. Now the other thing I do want to point out is that these points here, the intersections, C and D, are referring to the y values. So that would be y equals C and y equals D at those 2 points. Okay, so let's look at one example of that and then you guys will be done. Okay, so let's find the area. This I guess is example 4. Okay, find the area between x equals y squared and x equals 9. Okay, so first thing I want you to notice is that it's not y equals anymore. These are x equals equations. So when I set up my graph, y squared is going to open to the right. It's still a parabola, but it opens to the side. And then x equals 9, instead of being flat, it's going to be vertical. So that's x equals 9, that's x equals y squared. And then my area is still trapped between those two functions, just like that. So when I set up my integral, it's going to be area equals the integral of right minus left. So up here, I actually forgot to write that. But f of y is always going to be the function on the right side. And g of y is always going to be the function on the left side. Now, if you don't know your right from left, just turn your head to the side like this, and then you can see, like, look. And now you can see that f is on the top, g is on the bottom. Okay, but really, we're just going to talk about it in terms of right minus left. So if I'm looking at my new graph here, okay, this is the right side, so it has to come first. So I'll do 9 minus, and then this is the left side, y squared. Then from there, I need to know these intersection points here and here, which means I'm going to have to set my equations equal. So I would set y squared equal to 9. So find intersections. I'm going to let y squared equal 9. Square root both sides. Y equals plus or minus 3. Which means this top one is y equals positive 3. This bottom intersection is y equals negative 3. So negative 3 here, positive 3 here. And then for my antiderivative, integral of y is going to be 9y. Integral of y squared is going to be a third y cubed. And then I'd plug in 3, plug in negative 3, and then subtract. Okay, let's say you were doing this one all the way out. So 3 times 9 is going to be 27 minus. 3 plugged in here is 27. Divided by 3 is 9, but it's a minus in the middle. 27 minus 9 is 18. That's my upper value. Then for my lower value, I'm plugging in negative 3 times 9. That's a negative 27. And then negative 3 cubed here is negative 27. Divided by 3 is negative 9. But then I have my minus here in the middle. So if it's minus negative 9, that's really a plus 9, which comes out to be negative 18. Then remember that you're doing this minus that. So if it's 18 minus negative 18, then really that's a plus. It comes out to be 36. And then if you think about this space right here, that's how much area is encompassed in that section between the two graphs. Okay, that's the area. Okay? Good job. We'll look at more examples tomorrow.